this would be a 1, this would be a 2, all right? That's your radius. So it's the distance, so remember, the radius is the distance, right? From the L, this line right here, your x-axis is your L, to the what? Curve, f of x. F of x minus L will give you the length of that radius. F of x minus L. Got it?
L is just equal to whatever our y value is.
Right. L is equal to the y value of the line that you're rotating about. Okay? And what are we rotating about again? The x-axis. So then what's my L? 0, because the x-axis, y equals 0. When you're finding the r, you're subtracting the y value from a y value. The y value f of x minus the y value of the line that you're rotating about. You got it? You got it? Okay. If you don't get it, it's real simple. What's my f of x here? Radical x minus 2. So it's going to be v is equal to pi. And remember, it's in terms of x, right? So my upper bound is going to start at, my lower bound is at 0. Where do we stop at? X equals what? 4. So that means it's going to go from 0 to 4. 0 to 4. We integrate. Okay, it's how it's, so the 0 and the 4 are your boundaries, okay? Your x values, all right? Of my f of x, which is radical x divided by 2. That's my curve, right? Minus the what? 0, because I'm rotating about the x-axis. So the x-axis is L is equal to 0 here. Or y equals 0, all right? So y value. Quantity squared dx. Okay? Well, we don't need that 0, right? Okay, so basically all it really is I'm squaring the radical x over 2, right? Okay? I'm running out of room very fast here. So that means I'm going just pi. I'm just going to rewrite this for you guys, okay? So radical x over 2 minus 0 is just what? Radical x over 2, quantity what? Squared dx. Okay? Right?
Right.
When I square the radical, x is just going to be x, right? The square cancels out the radical. And then I square the 2 at the bottom, makes it a 4. Right? So it's going to be pi, the integral from 0 to 4, x divided by 4 dx. Okay? When you're dividing by 4, it's the same thing as multiplying by 1/4. It's a constant. Okay, let me say that again. When you're dividing by 4, it's the same thing as multiplying by what? 1/4. Therefore, the 1/4 is a constant here. I'm going to pull that constant out before I start doing the integral. So I'll pull out that 1/4. It's going to be pi divided by 4, the integral from 0 to 4, x dx. Look how clean that integral looks. See? What's the integral of x? X squared over 2, right? X squared over 2. So this is going to be equal to x squared over 2, and we are going to what? Evaluate that from 0 to 4. Got it? Okay? Now wait a second, I made a mistake, didn't I? Hold on, guys. I forgot my power 4 on the outside here. Right? Wow, when I did my notes, I even made I made a mathematical error. But I'm not looking at my notes. So watch this though. Now I go ahead and start plugging the 4, right? And I go minus and I plug in the 0. But you see that constant? There's another constant here. It's a what? I'm dividing by 2.
Well, it's 1/2.
But it's a 1/2. I like to go ahead and pull that constant out before I start plugging in 4 and 0. That's just me, all right? So basically it's going to be what? If I pull out the 1/2 multiplied to the pi over 4, that's already out there. It's going to be pi over 8. Then I plug in the 4 to the x, it'll be 4 squared. Then I plug the 0 to the x, which is 0 squared, right?
Can I ask how we got the x squared over 2 again? How we got it back?
Mm-hmm. Then what's 4 squared? 16. 0 squared is 0, right? So what's 16 minus 0? 16. So it's going to be 16 times pi over 8, which is 16 pi over 8. right? And what does that reduce to? What's 16 over 8 reduced to?
2. Wait.
2 pi.
Yeah.
That's my exact answer. If you want the approximate answer is 3.14, and it keeps going, right?
Mm.
Are y'all with me, class? Huh? What's that?
6.28 is 2 pi. Not pi.
Oh, yeah, 6.28. I'll just check to see if y'all paid attention. Good job. 6.28, right? So the volume of the what? The 3D solid looks like a what? A bowl, right? That's created. The volume of that 3D solid is 6.28 inches cubed, feet cubed. I don't know what the dimensions are here. Does that make sense? Right, inches cubed? So it's inches cubed. So the volume of this thing right here is 2 pi inches cubed, approximately 6.28 inches what? Cubed. Got it? Yes, sir.
I'm still stuck on the, where you got x squared over 2.
Yeah, I don't understand that either.
I might have made a
That's what I was
mistake.
trying to ask. Because you got x dx, and then you went from x dx to x squared over 2. But I thought we already plugged that in, so how did you get it back?
Remember, you took the integral of x. What's the
It is
integral of
x
x?
squared over 2.
Remember, it's already a power of 1, right?
Took away the squiggly.
You add a 1,
Oh.
you get x squared,
Now
right?
we're
And you
good.
divide by what?
Yep.
Oh,
2.
Gotcha. Sorry.
Right?
Yeah. We're good.
Questions?
Mm-mm.
I know calculus 2 is pulling on its machete already. It's ready to chop heads off, but don't let it. Just dodge it, man. Get it, okay? All right? So far, so good? It's showing its teeth already. All right? Y'all okay?
Mhm.
Trying to show you how to handle this stuff. Y'all got this. Okay, here we go. Let's go to the next example. And I apologize, I'm going to do a better job with the slides next time. I'm about to probably, when I print out the slides, I'm going to have to print it like just one slide for me each time when I put it up here, okay? Because you can barely see up here, but I know you got it in front of y'all. Let me see if I can get it focused. It is right beside you. Your notes and also some cheat sheets for you, man. I saw your hand raising my peripheral vision. I'm a bad dude, man. I'm a bad dude. Yeah, I shouldn't say that. Okay. All right. Here we go. You all right? So what do we got here?
The disk method?
Right, we're gonna find the volume of the slide formed by y equals sine of x. So what they did was, see, this is sine of x right here. Are y'all with me? Here, I'll just so y'all can see that I know how to do this kind of stuff, right? What's the radius of a unit circle? Right, 1, right? Remember sine of x, it starts here. 0 degrees, what's the sine of 0? 0, right? What's the sine of pi over 2? That's right, it's 1. Told y'all, man, back when I told y'all it's gonna come back. Right? And then what's the next one after pi over 2? It's what? Pi. Right? And what's the sine of pi? 0. And we can stop right there because we're going from 0 to what? Pi. And so this is the part of the sine function, right? Correct? That's correct. That's right. And so we got the shaded region under the curve, correct? All right? What are we gonna do? We're gonna rotate that shaded region under the curve around what axis here? It says about the x-axis. Okay? And when you do that, it's showing you right here, it's gonna create this 3D figure. See that? Looks like a lemon. All right? But notice to find the volume of that lemon, what the calculus, see, we don't have to do this, thank God. We got an awesome, we know calculus. These dudes are geniuses, man. This machine here that you got here, this integral, what it's gonna do for you, it's gonna cut that lemon into disk. But you ain't gonna see all that in the math. but it's gonna cut those limit into disk, right? And it's gonna find the volume of each of those disks, and it's gonna add it up for you, and you got your answer. That's what the integral is gonna do, okay? But how many disks are we cutting it up? Infinitely many. You understand? Infinitely many. How thick are these disks? They're so thick that you can't, or they're so small that you can't even, it looks so thin, you can't even tell the thickness, but it's got some thickness to it. Are you with me? And that thickness is called dx when you write the integral. Got it? Okay? Are you with me, class? Now that right there, what I just said is the most important thing in the math. What I just said right there is the most important thing, because if you don't understand why, you know what I'm saying, the concept, and I'm not being mathy, I'm being that simple, that plain with you guys, okay? That's all there is to it. Right? How many discs you see there? Well, I can count those discs, right? But really, to get the actual volume of that lemon, after we rotate that area under the curve, it's gonna cut it into so many discs you can't count. That's what infinitely many means, right? And you're gonna find the volume, the calculus is gonna find the volume of each of those discs using integration. You're gonna add them all up. Got it? The volume of each of those discs. And then you get the volume of the lemon, that 3D shape. Okay? Got it? Now, you're gonna see me throughout the lesson here. I'm gonna draw this little rectangle here. That speaks of the thickness of your disc, by the way. Okay? And what are we doing? I want to find the radius, right? The radius of each of the circles of each of those discs. Well, the radius is the distance from the axis of rotation, which is going to be your x-axis, right? To the what? The curve, right? So this right here is going to be your capital R sub x, which is what? Your f of x minus your L, right? What's your f of x here? What's the curve? What's the equation of the curve? Sine of x. That is your f of x. You understand? So this is my f of x. Are y'all with me? Okay. Minus. What's my L? What's the axis I'm rotating about? The zero, right? X-axis, which is L equals 0, Y equals 0, right? Okay. So it's going to be sine of x minus what? 0, which is equal to what? Sine of x. And the volume, to find the volume, what do we do? Volume is equal to pi times the integral from a to b of capital R sub x squared, what? Dx. See? And our R sub x is sine of x. That's all we need. So the volume is going to equal to pi, the integral from 0 to pi, because that is our interval. 0 to pi of sine of x, quantity squared, dx. Got it?
Is that formula for the volume on the paper?
The beginning. Yeah, no, none of that, no. It's in our notes, so I have to give you that at the beginning. But I got it right here. Up here as well, it's barely see it, okay? So if I square that, it's going to be v equals, writing way too big here, pi, the integral from 0 to pi, sine squared x dx. This is why I told you to, wanted you to come early, because look, remember that? What did we say in the warm-up? Can you take the integral of sine squared x?
Mm-hmm.
No. So we're going to have to go look at our trig identity, right? Right? And so what is the trig identity for sine squared x?
1/2.
Okay.
Cosine.
1/2 times 1 minus cosine. 1 minus cosine 2 theta, right? Or 2x here, right? This case. What? You see that? Okay. Are y'all okay, class? And I should have given some more room to write here. Oh, heck. Looks like it's this. Okay. So then now, here we go. Now we can take the integral of this thing. I'm gonna take out the 1/2. So v is equal to pi over 2. And I got, now watch this. When I take the integral, now for right now, I'm gonna leave the 0 and the pi off the integral. Simple. All right? Just so it can be, don't have to write so much. At the end, we'll bring it back. You got it? When I take the integral, I'm gonna take the integral of these two terms separately, so you can see the integral. I'm not gonna shortcut this. All right? Now, right now, for me, I can take the integral of this right now as I see it. Boom, I'm done with it. I want you to get to that level, okay? But I'm gonna separate it. So I'm gonna take the integral of 1 dx. It's like I multiply this dx inside here, right? And I'm gonna take the integral of this term separately. Are y'all with me, class? So the integral of 1 dx minus the integral of cosine 2x dx. Okay? So far, so good?
Mm-hmm.
Now, the first integral is pretty simple, right? It's just a constant. What's the integral of 1 dx? X. 1x. X, right? That's right. Good. Okay? So we know that's to be x. Okay. I gotta be careful here. Okay, we'll bring that back. We'll just write the x on top here. Are you all okay? That's x, right? Just gonna put a note there. It's x. And I'll write it later, okay? Now, let's deal with that cosine 2x. Remember what I talked to you earlier in the warm-up? You go to take the integral of this, you gotta look inside the what? Because we know the integral of cosine x is what? Look at your sheet. Sine x. We know it's sine x, right? And it's gonna be the same thing here, but we got this 2x we gotta deal with, right? And you gotta see the derivative of that 2x outside of the cosine, right? What's the derivative of 2x? 2. But do I, 2 dx, right? I see the dx. Do I see the 2? No. So I give it the 2. Right? That's right. And multiply by what? 1/2. Got it? So now the integral of 2 cosine 2x, the integral of cosine 2x 2 dx is just sine of 2x. So the integral of this, remember, you ignore the 2, you ignore the dx. You understand? Because we gave it the 2 and we undid it out here, right? So we take the integrals like you ignore the 2, and you're just going to take the integral of what? Cosine of what? 2 dx, which is what? Sine of 2x dx, of 2x, right? Sine of 2x. Are y'all with me?
Mm-hmm.
Okay? So it's going to be what? This right here, this integral right here, is going to be the sine of what? 2x with that 1/2 multiplied to it. Got it? Just like that. So here we go. So we got pi over 2. We got x minus 1/2 sine of what? 2x. Boy, I made a lot of mistakes on this one. It's weird. I do it by myself. I make mistakes, and I do it with y'all not making mistakes, which is good. I'm glad I made my mistakes early. Y'all with me, class? So now I'm just going to evaluate this from what? From 0 to what? To pi, right? Told you we'd bring it back later, right? Here we go. So we're going to do it. So v is equal to pi over 2. We plug in our pi, so it's going to be pi minus 1/2 sine of 2 pi. And then we go minus and we plug in the 0. 0 minus 1/2 sine of 2 times 0. Okay? Right? Give me some time to write that down. You okay? Oh, man. All right. love when we plug in zeros because most of the time most of the time, about all that stuff we plug in zero just goes away, just goes to what? A big fat zero? But be careful what about me saying that, it doesn't happen all the time, but most of the time it's gonna happen, right? And what all we're gonna do is just focus on what? That right there, okay? So therefore, V is equal to pi over 2, bracket. We got pi minus 1/2. What's the sign of 2 pi? 0, right? 0. Gosh, darn, I taught you all that a long time ago. I guess I didn't do a good job.
Oh, yeah, the absolute value.
Right, sign of 2 pi is 0?
Mm-hmm.
Okay. And what's 1/2 of 0? Oh, I love that, it's what? One big fat 0, right? And so we got volume is equal to what? Pi over 2 times pi, which is equal to pi squared divided by 2. And what is that? What's pi squared divided by 2? $4.93, right? There we go. Y'all okay, class? So the volume of that lemon is 4.934. Did it give us the units on that? No? So therefore, we just called it units. I forgot to write this cube. Could be inches cubed, it could be, are y'all with me? Ounces cubed, whatever the case may be. All right? Y'all getting this now? You see what we're doing? Get ready, you're gonna see me a lot for tutoring, okay? All right? If you're not getting it.
Uh-huh.
You okay? Oh man, good. Woo. All right. Right on time, break. We'll take a break, all right? Next we're gonna do the washer method.